So last class we had made a aerial view of a specific location, and I had chose the Indian Ocean between Durban, South Africa and Perth, Australia. So today we're going to do the same location, but we're going to do a side view. And so I'm going to draw in a coastline dipping down into an ocean basin and back up to the next coastline. And so for this, my Perth, Australia is located on the one side, and my Durban, South Africa is located on the other side. Now, if you have a continent in the center, yours is kind of going to be upside down with your continent in the center and your two locations and your ocean basins on either side. Now, the things that I want to put on here, I put on the name. These are along the 30 degrees latitude line in the southern hemisphere, so I'm just going to put that in as well. And the first thing I want to add on is my tectonic plates. Now, for me, the tectonic plates are moving apart from each other in the Indian Ocean. I'm going to label that this is the Indian Ocean. Here, I'm not going to draw on the water line yet, but it would be right across the center here. And on one side, I have the Australian plate, which is a continental plate. On the other side, I have the African plate, which is a continental plate. And these two are diverging apart. That's divergent seafloor spreading. And that is creating a increased ocean size there in the Indian Ocean. It is creating an ocean. Now, I am not going to get tsunamis at this location. I'm going to indicate that I'm not getting tsunamis there by drawing a tsunami warning symbol, a triangle with a wave inside of it. And then I'm just going to X that out so I know that that does not actually occur here. It does occur if you have convergent subduction. But I want to draw the difference between a tsunami and a regular wind wave. If there was a tsunami, then that would create an orbital movement of the water in the entire ocean basin. And that tsunami is going to be deeper. It's going to be faster. It's going to be lower. Or when it comes onto land, then it's going to get higher, but it's lower in the open ocean. It's going to be a lower swell, but a higher surf. And it's most importantly, it's going to be more destructive than a wind-caused wave. We'll get wind-caused waves in just a second here. But in the air, I want to draw the direction of the trade winds. Now, my location is right along the 30-degree latitude, so I'm going to have to choose one of them to stick with. I'm going to just, because mine is right on the border, I'm going to choose along the 0 to 30 degrees latitude. Because it could be either, since I'm right in the middle, I'm going to identify that. That's the trade winds from 0 to 30 degrees. And they're going to be pushing the water with it in the gyres. But what I asked next, actually, is that it makes the waves. And so in the open ocean, we're going to see swells occurring. Which are rolling in deep water. But then as that approaches the shallows, it's going to start to lift and crash into surf. And so in the swells where the wave is not touching the bottom, we see a full orbital movement of water, but the forward movement of energy in those waves. And then as the wave approaches the shallows, the bottom will slow and it will lift until it crashes. Which we know can make some beach dangers like riptides and undertows. Now, on the side opposite of this, I'm going to draw a sea breeze. And remember, a sea breeze is when I have warmer land. So that's going to cause a low pressure where air is rising. I have a colder ocean where air is sinking, and so the sea breeze is going to blow from the sea towards the land. I'm going to label that. And the sea breeze is going to create a cloudy skies where the air is rising. That's a small low pressure there. And we're going to get sunny skies over the ocean where air is sinking. That's a small high pressure system there. And that's because of this colder water and warmer land. But onto the, now that we have the sea breeze there, on the wave side, I'm going to draw a vertical arrow labeling the low and high pressure symbols that make the atmospheric winds. So these were local winds that were making the sea breeze, but on the other side, let's do for the atmospheric winds. And at 30 degrees latitude, this is a high pressure region because it is cooler than the equator. So my atmospheric winds are sinking, making that high pressure region, and that's going to create the outback desert that we see in Perth, Australia. And so I'm going to draw on here a little cactus. I don't know if they actually have cactuses there, but we do here in our desert, so that's typically what we use to represent the desert in terms of a plant. Maybe I could draw a kangaroo there, but that is a desert ecosystem. In South Africa, there's the savanna due to that desert there. And as that air pushes out from the high pressure, it is bent by the rotating earth to create the trade winds there. We're going to get that rotating earth in just a moment. But before we do that, I'm going to draw on the tides. So on the opposite tide of this wave, I want to show that during the king tide, I'm going to get a very large high tide and a very low tide. So I'm going to draw on that large tide here and show that the water is lifting up vertically. I'm going to have to move this high pressure cold water. And so it's above the sea level. So I'm going to write in that it's a high and spring tide that is lifting the water vertically here. And the reason why it's lifting the water vertically is because the sun and the moon are aligned. Now, in order to get a high tide, we're going to have the moon closest to the earth or furthest from, but we should be able to see the moon. And then if they're in line with each other to make the spring king tides, then the moon is going to be blocking out much of the sun, or where the sun is shining on the backside. So this is going to just be a crescent moon being seen here. But we also get spring tides when we have a full moon. Now, this moon is orbiting the Earth every 28 days, or just about a month. So since it's orbiting that 28 days, fluctuating between two springs and two highs, that means there's a 7-day tidal change for the spring and neap tides. But the Earth itself is rotating, and so the Earth, I'm going to draw that on the bottom somewhere where I have space. The Earth's rotation, and that's going to be over a 24-hour period. And that's going to be 2 highs and 2 low tides each 24 hours. So that makes a 6-hour tide change for the high and low, and the 7-day tide changes for the spring and neap. But then the entire Earth and moon are revolving around the sun. And as that happens, because the Earth is tilted, it creates the seasons. So that's a 365-day revolution of the Earth and the moon around the sun, and that creates the seasons. I guess that would be a season, 12 months, 4 seasons. So that'd be a 3-month seasons. There. In the water, then, the next one here, the trade winds are going to push the gyres in the same direction that they are moving. So between my 0 and 30 degrees, the gyre is being pushed in the same direction. Again, I'm going to have to label that because mine is between 2 locations. Oh, I did this. That should be between, it's going that way between 30 and 60 degrees. And so if it's between 30 and 60 degrees from the west towards the east, sorry about that, then that is going to push heated water with it as well. And so between the 30 and 60 degree latitude, what that means is that we are going to get the cold water on one side and warm water on the other side. And between the 30 and 60 degree latitude, or really between any of the areas, we're going to see that the west side will get colder waters. That's the west side of the continent. And the warm water will be over on the eastern side of the continent. And that can be exacerbated by the up and down wellings from the La Nina. So when we have an upwelling during La Nina, we're going to get extra cold water, and then we're also going to get droughts from La Nina. And then if we have warm water, which is since we have a downwelling during La Nina, we are going to get La Nina floods. Then we're going to have greenhouse gases like CO2. And that is going to allow sunlight to go through, but it's going to reflect heat off of it, creating climate change, which everything will be changed by climate change except for the plate tectonics or the moon and the sun's rotations. All right, so hopefully that works for you. You can make your drawing, submit that in, I'll make comments and see how you did.